So we're talking about the difference quotient. And so the difference quotient is this crazy formula right here. And the difference quotient always looks like this. So if you want to memorize the difference quotient, you can just, like I said, you just memorize that formula. It's f of x plus h minus f of x divided by h. And the first time you see this, it just seems like a completely random mathematical monstrosity. And there's a great mystery of what does it have to do with anything, and why is it important? Because it turns out we don't just, I'm not making you learn the difference quotient just to torture you. It turns out the difference quotient actually is really important in calculus. And let me kind of give you a brief explanation why. So we know that average rate of change is really important to us in this class. So average rate of change, average rate of change, or the way I guess the way I talk about it on the pages in the module is I talk about it as average velocity, just to be concrete. But I want to emphasize that the words rate of change and the word velocity are kind of interchangeable. Let's see, average, let me write it down here, average velocity. Because velocity is the rate of change of position. Like if I'm moving, then my velocity is a measure of how fast my position is changing. So velocity is a rate of change. It's just a specific kind of rate of change. It's the rate of change of my position. Whereas if you weren't talking about a moving object, like if you were talking about a chemical reaction, or you were talking about if you were running a business and you were talking about revenue, revenue might be changing, and your chemical reaction is changing. And so the rate at which those things change, that you'd call that a rate of change. So again, so I just hope that's not confusing, that when I write the notes, I often refer to velocity to be concrete, because I think everybody understands more or less what velocity is. But sometimes when you read the book and when I talk on these videos, I sometimes use the phrase rate of change. But those things are really the same thing. Okay, so sorry about going off track there. I just wanted to make sure there was no confusion there. Okay, so the average rate of change, so the average rate of change on the interval from A to B is, we know the formula for that. It's f of B minus f of A divided by B minus A. So that's the average rate of change formula that we know and love. And hopefully at this point, you recognize that formula really well. You say, oh yeah, I've used that formula a lot. I understand that formula, and so on. Okay, so what does that have to do with the difference quotient? And I mean, I guess if you look at them just on their surface, they're different, but they do have some similarities. So I mean, obviously they've got they're both fractions. They both have a function, and the function is in the numerator. So yeah, so these guys, these two guys are look like they're closely related, and in fact they are. They're basically the same thing. So yeah, so what I want to think about is what would the average rate of change. So let's see, let's consider the average rate of change. Instead of the interval from A to B, let's look at the average rate of change on the interval from X to X plus H. So, all right, so I can do that. So I just use this formula, and wherever I see an A in the formula, I put an X, and wherever I see a B in the formula, I put X plus H. So I get F of, okay, so instead of B, I write X plus H. And then instead of A, I write X. And then, okay, instead of B, I write X plus H. And instead of A, I write X minus X. And this, what I've got here, this is just the average rate of change formula, but instead of A, I use X, and instead of B, I use X plus H. And then now if you simplify this, you see that, okay, well, you can't really simplify the numerator because this X is trapped inside of the function. And so you don't try to cancel those X's or anything because that's illegal, because the function has to go first. So you can't really, there's nothing that can be simplified in the numerator. So the numerator is just going to be f of x plus h minus f of x. And then, but the denominator can be simplified because these parentheses aren't really doing anything. They were just there for grouping purposes. But since nothing's being multiplied or divided, those parentheses don't really need to be there. And so then the x's can knock each other out, and you just have h. And hey, and that right there, that's exactly the difference quotient. So that's the difference quotient right there. So the point here is that the difference quotient is really just, it's a special kind of average rate of change. It's just a very specific average rate of change. It's the average rate of change on the interval from x to x plus h. And so you might say, okay, I guess I understand that, but why do we need a special rate of change? I mean, what was wrong with what was wrong with the original average rate of change? Why do we need the special rate of change on the interval from x to x plus h? And the reason is because, and you'll see more of this in, I think, module 6, but the reason for this is that if you think back to when we were doing, how did we turn average rate of change into instantaneous rate of change? So let me erase some of this stuff here. So the way, if you think back to what we did earlier in the semester, is we turned average rate of change into instantaneous rate of change. And how did we do that? What we did was we looked at like an interval, And then here was the average rate of change. So the way that you turn the way that you turn average rate of change into instantaneous rate of change is you just let your intervals get really small. So for example, if I wanted to find the instantaneous rate of change at 3 seconds, then what I could do is I could look at the average rate of change on the interval from 3 to 4. And then I would look at the average rate of change from, say, 3 to 3.5. And then I would look at the average rate of change from 3 to 3.1. And then I would look at the average rate of change from 3 to 3.01, and so on. So I hope you remember doing that in the homework. So what's happening here, and then no, I'm just making these numbers up right now. I'm just going to make these numbers up for the purposes of this example. But maybe this number turns out to be 11. And then maybe this number turns out to be 10.7. And then maybe this number turns out to be 10.005. And then maybe this number turns out to be 10.003. So then what was the idea? What we did there was that we would look at this data, and based upon this data, we would guess or predict, that the instantaneous rate of change there's too much writing. Instantaneous rate of change, whoops. The instantaneous rate of change at x equals 3 is, so I would say 10. I would say that what's happening here is this. Think about what's happening on the left-hand side. These intervals are getting really, really small. These intervals are practically, this last interval is so tiny, it's practically just a single point. It's practically just the single point x is equal to 3. Right? This interval is really, really small. And so as these intervals get smaller and smaller and smaller, the average rate of change seems to be getting closer and closer to 10. So that's why we would say that the instantaneous rate of change is probably 10, because as this interval got smaller and smaller and smaller, these averages were getting closer and closer to 10. Okay, I hope that made sense. This is all a nice review of the stuff we've been doing recently. But now what you'd say is, well, wait, what does that have to do with the difference quotient? What does that have to do? It's like, okay, Travis, I understand all of that, but what does it have to do with the difference quotient? Well, the idea is what I could do is I could think about this interval. This interval right here, oops, uh-oh, now I did it. This interval right here, I could think about it as the interval from 3 to 3 plus 1. Right? I mean, 4 is 3 plus 1. And this interval I guess up an arrow, yeah. And this interval I could think about as the interval from 3 to 3 point, oh, whoops, sorry. I could think about this interval as the interval from 3 to 3 plus 0.5. And this interval I could think about as the interval from 3 to 3 plus 0.1. And this interval would just be the interval from 3 to 3 plus 0.01. So the moral is all of these intervals kind of have the form 3 comma 3 plus h, right? Or h is the thing that's changing, right? So if I mean, this interval is 3 and 3 plus something. This interval is 3 and 3 plus something. This interval is 3 and 3 plus something. So anyway, all of these intervals fit the same form, and that form is 3 comma 3 plus something. And that's starting to look like the difference quotient. Because the difference quotient was an average rate of change on an interval that looks like x comma x plus something. And actually, maybe I'll go ahead and stop my explanation. I mean, I could say more about this, but I probably, your eyes might be glazing over at this point. And we will say more about this in module 6. But the idea here is that when we, let me summarize in 1 or 2 sentences. In order to find the instantaneous rate of change, what we did is we looked at average rates of change over intervals that looked like 3 comma 3 plus h. Or we looked at intervals, we looked at the average rate of change over intervals that look like this. And the average rate of change over intervals that look like this, that's what the difference quotient is. And so the difference quotient is kind of a distillation of all the stuff we've been doing. In some sense, you've been using the difference quotient in your homework. You just didn't realize it because, like, as an example, wait, yeah, let me bring up my homework again. That when you did, can I go back? There we go. When you did the homework about average rates of change, you were using the difference quotient, you just didn't realize it. It was kind of hidden. And so now what we're doing is we're bringing it to light. We're saying, okay, you were using the difference quotient, you just didn't realize it. And now we're going to say, okay, this thing is the difference quotient, and now we're going to start paying attention to it because it'll make things easier. Okay, so that was really a long story. I hope it made kind of a little bit of sense. And now that's what the difference quotient is. So a 1-sentence summary is the difference quotient is a special kind of rate of change, and it's the special kind of rate of change that comes up when you try to turn average rate of change into instantaneous rate of change. And that's why it's so important to us, because that's what we want to do in this class. One of our main goals in this class is to be able to turn average rate of change into instantaneous rate of change. And the difference quotient is going to be the thing that allows us to do that, or it's going to facilitate that process. All right. So now there's the question of, well, how do you use it? So the thing I just erased that was an explanation of what the difference quotient is and why we care. But now there's a more practical question of how do you actually use it? And so let me just do this problem from your homework here, just to sort of show you how I would do it. So they want us to find the difference quotient for this function. Okay, so the way I think about the difference quotient is I think there are three ingredients. There's the f of x. And oh yeah, what am I looking? What are the three ingredients I'm talking about? So I think about three ingredients. There's the f of x, and then there's the f of x plus h. And then there's the h, which I probably won't even write down because the h is just h, so I don't really have to worry about it. And so when I'm working with the difference quotient, I write down all my ingredients. So I say, okay, well, f of x, well, the problem tells me what f of x is. F of x is negative x squared plus 2x plus 1. And now here's the tricky one. What's f of x plus h? So this is where you have to be careful. So you have to make sure you're real comfortable and real proficient with working with function notation. So the way f of x plus h works is I look at the formula for f of x, and everywhere I see an x, I replace it with x plus h. So the way I'm going to do this is I'm going to kind of write it I'm going to rewrite f of x, but everywhere I see an x, I'm going to put blank parentheses. So I get 2 and then times blank parentheses and then plus 1. So this is the kind of the schematic for the function f. And now what I'll do is I'll fill in what I fill in those parentheses with is x plus h. So x plus h goes there and x plus h goes there. So now if you compare what we have down here with what we have up here, you can see that, oh yeah, I basically have the same thing down here as I have above, only everywhere I see an x above, I have x plus h. Everywhere I have an x above, I have x plus h. But by setting up those parentheses the way I did, it helps me avoid making mistakes, because you have to make sure that, like, up here the entire x is getting squared. So that means that when you make that replacement, the entire x plus h has to get squared. And so by using the parentheses the way I did, it helps me guarantee that I'm doing the right thing. And likewise down here, the entire x is getting multiplied by the 2. So when the x turns into x plus h, the entire x plus h has to get multiplied by 2. And so those parentheses are really important. Okay. But we're not done with the problem yet. So we're just getting started. But now I've got my ingredients ready. So the three ingredients, actually, wait, let me put it over here. The three ingredients for the difference quotient are f of x, and that's f of x is right here. The other ingredient was f of x plus h. Okay, and f of x plus h is right here. And then the final ingredient was h, and okay, h is right here. So, all right, so now I'm ready to put them together in the formula. So let's see here. So, all right, so the formula says you do f of x plus h. So if I look at my formula, the first thing I have is f of x plus h. Okay, well, here's f of x plus h. So f of x plus h is negative x plus h squared plus 2 times x plus h plus 1. And then the next part of the difference quotient was minus f of x. All right, so I have a minus, and then now I'll write this yellow thing. I've got, it's negative x squared plus 2x plus 1. Okay, and now I've made a mistake, but it's an easy mistake to make. So if you're taking notes and you copied down exactly what I just wrote, you'll be okay. But I made a mistake because, yeah, as you know from the recent discussions, a great way to learn is to make mistakes, or making mistakes is an important part of learning. And so the mistake I made was that the idea is that this negative sign, this negative sign right here is the same as this negative sign right here. And this negative sign is supposed to affect all of f of x. But right now, this negative sign is only affecting, it's only affecting this term right here. This negative sign is having no impact on the rest of the yellow. And so the mistake I made here, which is a common mistake, which is why I made it, is you need parentheses here. And you know what? You don't actually need parentheses here, but I like to put them there just so I get in the habit of using parentheses appropriately. So like, right, these parentheses, what these parentheses are doing is they are grouping the function f of x plus h. They're kind of saying this is one group. And these parentheses, they are grouping the other ingredient, the f of x. And like I said, these first set of parentheses, they are optional because there's nothing in front of this function. So these parentheses really aren't doing anything mathematically. But like I said, I like to put them there because they don't hurt, you know, they're not wrong. They just aren't doing anything. But what they're doing for me is they're framing this first ingredient. But then the second batch of parentheses is very important. If you leave out these parentheses, you'll get the wrong answer because mathematically these parentheses are doing something. Okay, all right, I hope that made sense. And now, because we're still not done yet, but we're getting closer. And now what we just have to do is we just have to simplify this. So now we've done the hard part, we've set it all up, and now we just have to do the algebra of simplifying. So, okay, so let's see what we got here. So we've got negative x plus h squared plus 2 times x plus h plus 1. And now, so what I'm going to do is I'm going to get rid of these parentheses. I'm going to get rid of these parentheses, but the only way to get rid of the parentheses is if I distribute that subtraction. So the negative negative is going to make a positive. So it's going to be positive x squared, and then a minus a 2x, and then a minus 1. And then all of that is getting divided by h. And then let me see what now. Well, okay. Oh, well, there's some cancellations that can happen now, right? Cancellation right out that I can see right away is here's a positive 1 and here's a negative 1. So those guys can knock each other out. But now, oh, but this is a multiple choice question. So I see that, I guess I'm not done yet, because either I made a mistake or there's still some simplifications to do, because none of my answer, what I have written here is a fraction, and none of my answer choices have fractions. So I don't think I made a mistake. All this means is it means that there's more simplification to do. So, all right, so let's keep going. So, okay, well, here's something I might try. I might try distributing this multiplication. And I also might try doing FOIL right here. So expanding that expression. So, all right, so let's do those two things. So I'm going to have a negative, and when I do FOIL to this, I get, well, let me see here. Let me clear out some space here. So when I do FOIL here, what I'm doing is I'm doing x plus h squared. And so x plus h squared is, oh yeah, that's a good point. Let me make another mistake. So if you're thinking, oh, x plus h squared, that's just equal to x squared plus h squared. I hope you're not, well, if you're thinking that, it's okay to think that once, but then you should realize that that is a mistake and never think that again. Because when you do x plus h squared means this. And you should know that when you multiply two binomials like this, you have to do FOIL. And so you get x squared plus 2xh plus h squared. So you do get an x squared and an h squared, but you also get this you got the O and the I in FOIL that give you 2xh. So don't make this mistake, or make this mistake once and then never make it again. Remember that you got to do FOIL. Okay, so anyway, so when we do FOIL here, like I said, we did it over here. You got x squared plus 2xh plus h squared. So these difference quotient problems, they're long. So there's not really any shortcut. You just have to do the work. Okay, and then when we distribute here, we're going to get 2x plus 2h. So they're long, but hopefully they're not hard. So there's a difference, right? They're just because something has a lot of steps, as long as each step is easy, then that's okay. And that's kind of the way I want you to think about the difference quotient. Is I want you to think, okay, it has a lot of steps, but each step is not too hard. So I think I can do it. You just have to practice. So, all right, so we're getting closer here. So now what we see is, okay, yeah, now I see that there's a there's a 2x, a positive 2x here, and a negative 2x there. So we're getting closer, but we're still not done yet. So let's see. So what's the next thing I'm going to do? The next thing I'll do is I'll distribute this minus sign. So I want to get rid of these parentheses, and the only way to get rid of those parentheses is to distribute that minus sign. All right, so again, you just have to take this slow and steady. So all right, so we get a negative x squared, and then a minus 2xh, and then a minus h squared. And then what we still have is we still have a 2h, a plus a 2h, and we still have a plus an x squared. And all of that is getting divided by h. Okay, so now I hope for more cancellations. So I look at this and I see, okay, there's a positive x squared and a negative x squared. So great. So that positive x squared and that negative h squared can go away. All right, but I'm still not done, because I look at this and I think, doggone it, this still isn't one. I still don't have, none of my answer choices have a fraction. And I still am seeing a fraction here. So there's still more simplification I can do. And so I think, well, gosh, what simplification can I do here? Well, now if I look at the numerator, everything in the numerator has an h. So why don't we factor that h out? So if I factor the h out of the numerator, I get h times, okay, so let's see what's left. There's a negative 2x. And I factored the h out, so there's no h. And then a minus h squared. But I factored out one of the h's. So the h squared will just turn into an h to the first because I factored one of the h's out already. And then plus 2. Because of that, again, the 2h just turns into a 2 if you factor the h out. And then don't forget that we're dividing by h. Okay, so what I did in that step was I just factored the h out of the numerator. And now we see, now I think we're done, finally, because you have a factor of h in the numerator that can cancel with the factor of h in the denominator. And so now since there's not a fraction anymore, now like the only thing we have left, this is just equal to negative 2x minus h plus 2. And if I lived a good life, that's one of my answer choices. Oh, it's in fact the very first one. Negative 2x minus h plus 2. And I think, yeah, that looks like it's right. So, all right, so I'll submit that, make sure I didn't make a mistake, and I didn't. Okay, so that is a difference quotient problem. Yeah, so the idea behind the difference quotient is it's just a lot of algebra. That if you want, in order to do a difference quotient problem, it's just a lot of algebra. Oh, but wait a minute. Let's talk about what this is. Well, I'm going to let you ask questions, but after you're done asking questions, I want to show you what this is good for, because this is actually really useful. This expression here, this was a lot of work to find this. And so if I were you, I would say this was a lot of work. This better be very useful. This better make my life better, because I worked really hard to find it. And what I want to do is I want to show you that actually this will make our life better. Okay, but before I do that, you ask me any comments or questions about what we did on this problem in order to get this answer.
Um, I don't think so, honestly. Your
Okay.
explanation was very well detailed, and I was really having trouble with the setup for the most part, and I probably would have done that x squared 8 squared plus 8 squared thing. So
Uh-huh.
I'm glad you went over that.
Okay, good.
Yeah, thank you. That actually really helped.
All right. All right, good, good. All right, any other comments or questions?
Um, Not at the moment.
All right.
But
So
obviously, like you said, what's the point of that
yeah.
answer?
All right, well, yeah, and if anybody else has any comments or questions, please feel free to, chime in. You can ask using your microphone, or you can type it in the chat window so that I can see it there. Okay, so yeah, since we've done all this hard work, let's talk about what this is good for. So I want to find here's an example problem. Find the instantaneous rate of change of this function. So it's this function that we've been working on. So the instantaneous rate of change of this function at x is equal to, say, 5. So the idea would be that maybe this function represents my position. So maybe this function, I'm driving a car, and this function represents my position. Or maybe this function represents my profit from the business that I'm running. So what I can do now is I can ask, well, what's my instantaneous velocity at the moment 5 seconds? If this is my position function, then what's my instantaneous velocity at x is equal to 5? And I claim that this guy right here, this is going to help us answer that question. So the way we would normally do this is we would say, okay, let's think about the way we did this in the homework. The way we did this in the homework was, we said, okay, we would take an interval, and the interval would maybe be like, the first interval we would do is maybe be 5 to 6. And then the next interval we would do would be 5 to, say, 5.1. And the next interval we would do would be 5 to 5.01. And then what we would do over here is we would calculate the average rate of change, and we'd try to see a pattern. And so hopefully that makes sense. And the idea is this formula, this actually is the formula for the average rate of change. It's all simplified and perfect. That if you go, so what you could go home tonight and do is is use the average rate of change formula for this function from 5 to 6. But what you'll get is, the idea here is 6 6 is 5 plus 1. So I claim that I can just, let me think here. The average rate of change is gonna be, it's gonna be -2 times 5 minus 1 plus 2. And now you might, if I were you, I'd be saying, wait, where did that come from? So, well, first of all, let's see what you get. You get -10 minus 1 makes 11. So you get -9. I think I did that right. -10 plus 2 makes -8, minus 1 makes -9. Yeah, you get -9. And you say, well, how did I do that so fast? Well, because the idea here is that x is equal to 5. We said that right here. We said x is equal to 5. So I'm going to put 5 into that formula right there because x is equal to 5. And what h is h is what we're adding to 5 to get the second number. So for example, in this one, h is 0.1. And in this one, h is 0.01. And so the moral is that I can compute these average rates of change really fast now, simply using this formula. I can say, oh, okay, this average rate of change is going to be -2 times 5 minus 0.1 this time plus 2. And the reason I'm subtracting 0.1 this time was because up here, the h was equal to 1 because 6 is 5 plus 1. But here, the h is 1. Or sorry, here the h is 0.1. So in this formula, instead of h, I put 0.1. And in this one, it's going to be the same thing, -2 times 5 minus 0.01 plus 2. And so you can do that really fast. So anyway, so that might have been a little bit, that might have not been super clear. If what I just said made sense, then that's awesome. If it didn't make sense, then you're gonna have to trust me a little bit. That the moral is that the difference quotient is just it's a simplified version of the average rate of change. And so being able to compute average rates of change in situations like this is very important to us. And so what the difference quotient is going to allow us to do is find the average rates of change in a very efficient manner. So,
I get that.
okay. All right. So that's, there you go. That is everything you ever wanted to know about the difference quotient.